Alright, this video is about the periodic table groups and trends. So we've got the periodic table is broken down into three main groups: metals, metalloids, and nonmetals. The metals are all going to be on this side of the periodic table. On the left side of the blue line, so all of these are metals, including aluminum, and the rest of the elements that touch the line are not metals. So all of these down here, and all of these up here, and then all of these down here. So the only element to the left of that line, of this blue line right here, this one, that's not a metal is hydrogen. Okay? So, next we will have metalloids, and metalloids are elements that have both properties of metals and nonmetals. So let's write that down here. Both properties of metals and nonmetals. Okay, and those elements can be found right between the metals and the nonmetals along that blue staircase. So boron and silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. These guys down here are new, but I'm assuming that they're probably metalloidish too, even though they don't stick around for very long. They're too heavy. Alright, and then the last we have the nonmetals, and the nonmetals are going to be all the rest of the elements. All of these, and hydrogen. Alright, and so one thing that I want to clarify before we move any further into this is the state of matter that each of these are in at room temperature. And so I'm going to circle the gases in red. So anything that's a gas at room temperature, on a large classroom periodic table, usually the element symbol will be written in red, and they will be all of the noble gases are gases at room temperature, and then fluorine and chlorine, oxygen, nitrogen, and hydrogen. Okay, so non-metal does not have to be a gas. It's a misconception. Carbon is a non-metal and it's a solid. Its natural form is charcoal or diamond. So that's definitely not a gas. Alright, and then the liquids at room temperature I'm going to circle in blue, and there are only two of them. One is bromine. So one is the bromine, and then the other one is mercury. So bromine is a liquid nonmetal at room temperature, and mercury is a liquid metal at room temperature. Alright, and then metals, metalloids, and nonmetals can be broken down further into different groups. And so the alkali metals is this first group right here. And that is known as group 1 or 1A. Alright, and then the second group is going to be the alkaline earth metals, and it's going to be all of these. And it's known as group 2 or 2A. And then next are the halogens, and they are down here at this end. Oops. And that's group 17 or 7A. And then the last are the noble gases. And it's usually the group that everyone's the most familiar with. It's the last group. So this group 18 or 8A. All right, and the transition metals. The transition metals are down here. Oops. So all of those across the bottom in the middle, these are the B elements. So you notice in the other groups, I would say 1A, 2A, 7A, 8A, well down here, down low, are the B elements. And those are all transition. And then the inner transition metals, as you can see right here, this is number 57 and it ends at 71, and it fits right between 56 and 72. So really the periodic table should be split right here and be twice as long as it is. So they pull these out to make the periodic table shorter so it can fit on one piece of paper. So the inner transition metals are down here, and they're called that because they go inside the other transition metals on the periodic table. You'll also see them referred to as the actinide and lanthanide series. So now we're going to talk about the trends. Before we can talk about the trends, I need to define these words. So electronegativity is an atom's ability to pull the outer electrons closer to the nucleus. All right, and the trend is on the periodic table. Now we ignore the noble gases, so noble gases are excluded. So I'm going to black those out. And the trend goes to the right and up on the periodic table. So the most electronegative element on the periodic table is going to be fluorine because it's furthest to the right and up. So I'm going to write that over here. Fluorine is the most electronegative element. All right. And next is atomic radius. All right, so atomic radius it describes the size of the atom. So the larger the radius, the larger the atom is. And I want you to think about this in terms of electronegativity. If the element has a large electronegativity, like, for instance, fluorine, then it means it's pulling its electrons in the outer shell right, in closer. So that means it's going to make it smaller. So if electronegativity increases to the right and increases going up, then that means that atomic radius is going to increase going the opposite direction. So the trend for atomic radius, it increases to the left and down. And this is also really due to something else as well that we're not going to talk about quite yet. But this should get the point across. So the largest atom on the periodic table is francium. All right, and then the two last things that we have to talk about are electron affinity and ionization energy. Now, electron affinity is simply a love for electrons. To have an affinity for something is to have a fondness for it. So, electron affinity is a love of electrons. And ionization energy is the energy required to remove an outer shell electron. So the energy required to remove an electron from valence shell. So if you have an atom that has a love of electrons, then they would want to pull it in close, right? You love someone, you want to pull them in close. So this is going to have the same trend as electronegativity, because electronegative atoms pull their electrons in close. So electron affinity increases with electronegativity. And ionization energy does too, because if they're holding their electrons in really close, it's going to be harder to remove those electrons. You think about a football player, if they have the football tucked and they're holding it really, really tight and they're running with it, it's going to take a whole lot more energy to remove that football than it would if they were just holding the football straight out with one hand. It wouldn't take very much energy to knock that football out at all. So if it's really, really electronegative, then it's pulling its electrons in close, and so it's going to require more ionization energy to remove it. And there are other factors that add to that, but this should get you started just using the trends. And so both of these increase to the right and going up the periodic table.